Hello everyone, my name is Andrew Penland, but I also use the identity Octopus, and to be honest, that's the one that I find more comfortable and preferable. However you choose to call me, I'm happy to meet you. I'm going to be one of the facilitators for Complexity Weekend in April this year, and I wanted to share some thoughts that I've been having recently about different kinds of work I've done, different kinds of ideas I've seen, things that interest me, and questions that I'm very curious about. Recently, someone asked me, how do you find the edges of your thoughts? I thought that was such a profound question. As a mathematician, I'm familiar with the concept of an edge in several ways. In graph theory, an edge is something that connects two things. Maybe there is a sense in which our thoughts have a topology or can be viewed as a metric space. I like that idea, especially because if you look at the fact that there are certain semiotic things and syntactic things that seem to occur over and over again. Just the fact that there are common errors seems to suggest to me that you can put a metric on the space of ideas, or at least that you can think about it topologically and geometrically. The line between what is valid and not valid in mathematics is not so clear to me. And especially as an educator, I'm constantly encountering common mistakes in places where students are confused. I think one thing to think about is, how do we know what is true as quote-unquote experts or scientists? My answer to this question, how do you find the edges of your thoughts, was, I begin with the thing that I know that I'm 100% certain about, and then I see where I can go from there. And this is actually the mathematician's process of beginning with something that is known and then seeing what is accessible that is unknown from there. So of course what I'm talking about here, because my answer involved knowing something certainly and then exploring from there, the question of how I know, or any of us know, something with complete certainty, of course, is epistemology. Mathematical epistemology is especially interesting to me as a mathematician because we can begin with something that is very well known in the sense that no one disputes, for instance, the Pythagorean. But a student will be tempted to say the Pythagorean theorem says a squared plus b squared equals c squared, which doesn't even make any sense to a mathematician because a, b, and c haven't been quantified. Is this true for all real numbers? Is this true? What's happening here? Of course, we need to add the statement, if a and b are legs of a right triangle and c is the hypotenuse, then the statement is true. Then the question is, how do we know it's true? So there's sort of two extremes that we could look at, I think, that form a continuum. 2 points that I'd like to start with exploring this topology of this idea, of these thoughts, is a robot is just programmed to accept this. The robot will agree, and many students would want it to be the case that they can just accept my ideas as their ideas. On the other hand, we might have a level at which we have a formal proof. But then as I look at this, I think there's another way of looking at this as sort of orthogonal, which is looking at experiences. And I almost said experiments, and I think that they're highly related. If you generate lots of right triangles and take their measurements, you will observe this fact. And so what do we know and believe about mathematics or about anything else? And when we know and believe something like the Pythagorean theorem, it's very tempting to never ask why. If we do ask why, then we're in a situation where we're moving away from the robot towards experiences and experiments, or towards proof, or I think ideally, we're continuing in sort of a two-dimensional vein. When we ask questions, we often expect an answer, but I'm not sure that that's the ideal. My perspective on mathematics has been highly influenced by the fact that I wasn't always the kind of person who was good at math. I used to have this phrase that I would throw around in my mind, which said, an answer is just a question's way of making more questions. And I love this because it hints at the exponential growth of curiosity. When you think you have an answer, you're only going to... So you answer those questions, but it just keeps growing. The only change I would make to this from my younger days is I would delete just. To put the word just in there gives answers too little credit for the role that they play. I don't want this just to be about my private sort of thoughts, though. So in considering this, I want to connect it to ideas from complexity science that other people have considered. The way that this connects to complexity for me is in the idea of a bifurcation. Even the simplest question that we can imagine, we ask yes or no, it changes the next question that we ask, the basic idea of a decision tree. Bifurcations became popular in looking at May's equation, how the behavior of the system changed depending on the parameter. Bifurcations existed even to the ancient Greeks, who knew that the coefficients of a polynomial a, b, and c would change the number of real roots that a polynomial had. What they didn't have was imaginary numbers. This is very personal for me to share, but I often feel this conflict between my academic identity of Andrew Penland, the name that's on my driver's license, and my internal feelings of resonating with the idea of being an octopus. So depending on where I am and in which context, I have to flip a switch. And that's a type of bifurcation as well. And I think that if we look at the topology of thoughts that I mentioned earlier, we think about information as having a shape, that we see this often both in more formal computational and mathematical ideas of information and also in our informal human experiences. There's a sense in which being able to find the edge, in this case as a boundary, between one idea and another can be really powerful and a really powerful place to be. But I personally don't feel that I have the tools to navigate this yet. Another analogy would be a phase transition. You can think about mathematical problems. We've all had that experience where the professor or the lecturer was saying something and we were on board right until this sudden moment. It felt like we fell off the cliff. And what about mathematics makes those questions suddenly difficult? How can we analyze that? So far I've focused on thinking about what the questions are, how the questions can be formulated. But I think I've left out a crucial variable, which is who is asking the question. And that brings us into questions of identity. One thing I'm interested in is the emergence of a new phenomenon called Web3, or the metaverse. While these might not quite be the same thing, they're often used as synonyms, in which users will often use pseudonyms or remain anonymous. If we accept that this is going to be something that is increasingly possible, that people will be able to choose their identities that feel the best to them and represent these in a digital space, I'm extremely curious about what this might do for the future of mathematical and scientific and engineering research. We're already struggling, to be frank, so I'm grateful to another Complexity Weekend facilitator who has already pointed out that second-order cybernetics back in the late 1960s and early 1970s already looked at the question of self-referentiality in these systems and acknowledged that who is asking the question matters. In other words, the researcher is part of the system. I'm not sure that's something that I was really aware of. Knowing that this second-order cybernetics exists, I now have a totally different perspective on how to frame this discussion. So I appreciate you listening as I shared these thoughts. I look forward to seeing what your thoughts are. To be honest, at the moment, I'm a little apprehensive because I come into this space basically only with questions. I'm pretty far from my field of expertise in discrete mathematics, algorithms, abstract algebra, those types of subjects, and I'm dealing with things that I'm just now starting to be able to ask the right questions about. But I'm very, very eager to learn, and I'm excited to see what ideas you have to share and what we can figure out together. Please reach out to me if you have any questions or ideas. I'd love to work on these things. Thank you all.